our code editor. So to do so, we have to assign it a name. So we can say the name is image call. Now, ili tupate import that image collection, there are two ways we can do it. So the first way, we can move over to the Google Earth Engine platform and move to the datasets tab. And we can search for whatever dataset we're interested in. So in this case, we can just use Sentinel. Yeah. So under Sentinel, we have two categories. We have surface reflectance and we have top of the atmosphere reflectance. So in this particular session, we are going to go with surface reflectance. Now, the code snippet we're interested in is this one right here, called EE.image collection, Copernicus Sentinel-2 SR harmonized. So the EE, we all know it's Earth Engine. Then that .image collection is just to show that whatever it is we're importing is an image collection. And this because with Earth Engine, we have different kinds of datasets. So we can work with vector datasets, we can work with raster datasets. And as for the Copernicus, whatever is inside the double quotation marks, that's just the name of your image collection. That's the assigned name it's been given. So I can simply copy and paste it right there, and I add a semicolon. So the thing with JavaScript, whatever statement you're going to write, it's imperative lazima tuweke the semicolon to conclude that statement. Yeah, so alternatively, if you want to search a particular data set, you can just use the search bar up on top. Maybe Sentinel-2. Yeah. So the search results will show up right here. So you choose whatever data set you're interested in. So you can click on the multispectral Sentinel-2 MSI. So this window will pop up having the description, the bands, the image properties, and the terms of use. And if you look closely, right here, we also have the code snippet you can use to import our image collection. Likewise, we can also use the import button right here. So on using the import button, we'll find that imekuwa imported hapa at the top, variable image collection with these details right here. So if you are to import your image collection using this method, you don't have to repeat yourself hapa. You can just use it directly as it is. So after loading our image collection, we loaded our feature collection. Yeah. Now the sequence was still the same. We save our feature call. That's the name of the collection. Or rather, you can either opt to actually assign a feature collection as it is by hard coding the name of the feature collection. Yeah. So whatever goes inside this normal parenthesis hapa is more like that file path ambo it leads to that feature collection once you may upload onto your Google Earth Engine. Again, instead of doing that, You can also opt to move over to your assets tab and navigate to where your feature collection is or where your shapefile is. And using this arrow right here, we simply import and it will show up right here. So if you decide to change the name to maybe your feature call, you can decide to work with that. Yeah. Yeah, so that's what we had discussed last session. Now, alternatively, if you wanted to work on a particular area of interest and you don't want to go this route of importing a feature collection this normal way, you can opt to go to the dataset catalog and search for something called Faugul. So with Faugul has the same idea. It has a bank that has those different administrative units for regions all over the world. So we can maybe click the first one. So these are our search results. Maybe you can click on this. Now, to import our feature collection, we can simply copy this code snippet right here. And paste it there. So, rather than importing your own shapefiles, you can also opt to use whatever is provided by Google Earth Engine. Now, in order to use it, we have to understand the properties of this data set. Now, if we look closely, we have our description, we have the table schema, and we have the terms of use. So on table schema, these are the fields that are present. We have the name, the type, and the description. So the name is simply the name of that column in that particular table. The type is the type of that data type that is present within that particular column. And the description is simply what it means. So if you get to understand what this description means, you can simply use it to filter out your particular area of interest. That's also another method of working with feature collections. So that said and done, I've imported my feature collection. Let me remove this. Now I've imported my feature collection called feature call. I renamed it. Now the feature collection the shapefile I had imported was my shapefile for the Nyeri town constituency. But on your end, you can use whatever shapefile you have. So what I wanted to do was to convert my shapefile for my area of interest into a geometry. Now we said that a geometry, well, rather when you convert something into a geometry, we are simply telling the Earth Engine API that I have my area of interest, but because I know you might not be able to understand that it's a polygon of interest, let me convert it into a geometry so that it can understand and be able to do various operations like clipping. Now, given that I already have my constituency as it is, I can simply convert it into a geometry. So I can say I can say geometry is equivalent to feature call dot geometry. This is a recap of what we did last time. Now, once I've obtained my geometry from a particular area of interest, I now decide to filter my image collection. So, last time, we looked at one approach of doing the same, whereby we filtered it step by step. So we started with filtering for cloud cover. So filtering for cloud cover, we had initially said that these images possess clouds, because they are taken on various places on the Earth's surface. So because we understand that these images are bound to contain clouds, what we want to do, we want to get the images that have the least amount of cloud cover on those images. So to filter for cloud cover, we simply say filter 1 is equivalent to our image collection that we had imported, dot filter, ee.filter, dot lt. Last week we had said the lt stands for less than. Then right here the lt, because this is Sentinel, we use cloud pixel percentage. And the last argument in that bracket is the percentage level. So let's say 20. So let me repeat what we discussed pali cloud pixel percentage imetoka. Now, our data set was the harmonized Sentinel-2 MSI level 2A. Now, when we look at the image properties, right here we have the cloudy pixel percentage. So this is the field that we're going to use to filter the amount of cloud cover we want to see in our images. So the thing is this: when these images are collected by these various satellites, they have to be arranged in a certain way. So the field that we use to represent the cloud cover is this one, cloudy pixel percentage. Now for Landsat, you won't see it being written cloudy pixel percentage. Instead, you'll see something else. Let me show you. So let's look at Landsat 9. Then we go to surface reflectance tier 1. Now, if you look at the image properties, we don't have cloudy pixel percentage. What we have is just cloud cover. And the range we've been given is from 0 to 100. So based on the dataset that you're using, the fields we use to filter vary. Yeah, so we have the filter for cloud cover. Then you had the filter for dates. So with the filter for dates, we're going to take our first filtered set, which is the filter 1 sasa, after tumeondoa the cloud cover ambayo tutaki. We now want to specify the time frame we want our images. Now, before I proceed, with this cloudy pixel percentage of 20, I'm simply telling the Earth Engine API that I need these images, but I needed to make sure that whatever images utanipa, the coverage of clouds katika image haipiti 20%. Hiyo ndo maana yake tu. So I'm saying, get me images where the image coverage of that image, the cloud coverage of that image is less than 20%. Always repeat it, 20%. Now filtering for dates, we can say filter 2 is equivalent to filter 1 dot filter dot filter dot date. Now we have two arguments. So the first argument is the start date, and the second one is the stop date. Now, the normal formatting for dates in Google Earth Engine, it starts with the year, the month, and then the day. So I've simply said that whatever images utaniletea, I want it from the first day of January to the last day of January. Nothing beyond that. Then the final filter. Final filter. We are filtering for bounds. So in other words, images, easy images tutaletewa, but now we want these images zero for a particular area. So now that area ni geometry ambayo tumeleta hapa, ambayo ni Nyeri town sasa. So we had said your filter 3 will be filter 2 dot filter e dot filter dot bounds. Yeah. Then our bounds sasa, whatever inatusaidia sasa ku restrict your aerial coverage ya hizo images sasa ni your geometry ambayo tumecreate huko juu. Now, alternatively, badala kufanya hivi step by step, unaweza amua uzilete hizi filters hapa juu. Now let me show you. Oh, by the way, naenda haraka sana. I slow down. Hata mtanjibu. I just want to recap, so pengine that's why nime speed up sana. But ni sawa, I'll slow down. Hadi naweza rejelea tu tena. So, tumesema we load our image collection ambayo iko na hizo images ambazo tunataka. Then we import our feature collection. So nikaonyesha the various ways unaweza import feature collection zako. Then your feature collection convert into a geometry. Reason being, ukiimport feature collection yako, it's not enough. So unapata katika maneno ya JS, so we have those basic geometrical entities, points, lines na polygons. So nikispecify kwamba feature collection is a geometry, it's like naiambia ina conform to one of those three, points, lines ama polygons. Then kutoka hapo tukasema we now want to filter hizo images zetu. Like we want to specify ni images aina gani tunataka. Na tukasema we can do it mara tatu. We filter for cloud cover, we filter for dates, and we filter to get images ambayo ina cover just the area of interest. Si mpaka hapo tuko sawa. Now, the first filter was for the cloud cover. Yeah? On my left or my right?
Yeah. Have you declared the variables?
Yeah. Now, I have this very, very bad habit ya kusahau kwamba I work with JavaScript. Sasa wajua with Python, si lazima utumie the variable keyword. But in JavaScript, lazima utumie hiyo var. So the var, kazi yake ni kuspecify kwamba whatever it is unaandika is actually a variable. Like it's a named memory location that is going to store something. So in a language kama Python, si lazima utumie variables, lazima utumie let, si lazima utumie const. But with JavaScript, hii var keyword lazima iwe hapo. So, asante kwa kunikumbusha. So hapa inafaa iwe var, hapa inafaa iwe var. Yeah. So, niko nasema badala ya kuzifanyia hizi filters huku chini, you can opt uzifanye tayari huko juu. So ndio avoid kusema filter 1 equals this, filter 2 equals this, filter 3 equals this. So let me show you how. Now, we gave our image collection ambayo to import a name called image call. Now, at the end of every statement, lazima tumalize na a semicolon. So what you do, tunaondoa tu semicolon, alafu hizi filter zetu tazileta tu huku juu. So I can just cut, kisha nyeke ako ka dot, naona kwa dot mbili kinamna hivyo. So I can decide ni enter, nisikume tu kitu hapa chini. Ndo sasa ile wakati na view code editor yangu kusiona a lot of overlapping code towards hiyo pande, si ndio? Like nipate kuiona tu in one space, ndo ni avoid scroll. Yeah, that's why nimeifanya hiyo enter. Then nakuja nina cut hii ya chini, alafu naileta huku juu. Okay. So in short, the dot filter part nazisukuma tu nazipeleka huku juu. So I just make one composite filter. Then the same applies for bounds. Now because bounds ni hiyo filter ya mwisho, naweza chukua hiyo semicolon yake, alafu nisukume huko juu. Then hizi hapa chini sasa naweza ziondoa tu, I don't need them. Yeah. So hapa I have my image collection called image call. So nimeiload, alafu nika apply those various filters. Then tayari my AI may convert into geometry. So chenye kimebaki sasa, chenye sikume kitu huku juu. Yeah. So the reason why nimesukuma my geometry huku juu, sikutaka hiyo maneno kwamba I'm filtering for bounds, but hiyo Earth Engine API inashangaa hii geometry imetoka wapi, yeti iko chini yake. So nimesukuma tu huko juu. And that's because unapata zingine most of these codes they just run sequentially. So inaanza line ya kwanza, ya pili hivyo hadi chini. Now, given that we have done our filters, we can check for the number of images ambazo ziko present. So we say print. So I'm just using a print statement kuonyesha kwamba utaniangalia the number of images ambazo zina qualify based on these parameters, alafu you'll display it on my console. So I'll simply say image call dot size, like that. So if I run, tukiangalia hapa pale kumeandikwa console, we see the number 2. So 2 represents the number of images ambayo the Earth Engine API imeangalia ikaona ina match my search criteria. So once I've confirmed ya kwamba images ambazo niko nazo they're actually present, I can form my composites. So in Earth Engine API, we have two kinds of composites. We have the median composite and the mosaic composite. So, generally speaking, they more or less give you the same thing, but there's a bit of a disparity. So last week, tulisema, kama the difference between the two, hata si kitu kubwa as such. Like median composite just give you the median pixel values for the images in that stack. Alafu the mosaic composite inaangalia tu images ambayo inaona ya kwanza, alafu inarushiwa tu whatever is present. Like that's in the simplest terms venye hiyo maneno inaenda. So we can decide to use either. Tunaweza tumia tu our mosaic composite hapa. So we say our mosaic composite will be my image collection dot mosaic, like that. Then with that in mind, whatever is left is just to add our images to our viewport. So to do that, we say map dot add layer. Then within the add layer, inafaa ichukue 3 arguments. The first argument ni the image unataka kuiload hapa kwa viewport yako. The second argument ni the visualization parameters, like how you want to see the image, whether it's in true color or false color, we want to specify. Then the last argument is simply the name of that layer. So we can start by creating those parameters sasa ku visualize. So commonly we can just use a dictionary. So we can say where these parameters is equivalent to a dictionary. Now whatever inaingia hapa katika dictionary ni 3 things: the minimum value, which is 0.0, the maximum value. So for Sentinel we can, okay, those maximum and minimum values na kwanga tu zimepewa katika hizi informations hapa. Let me see. Kwa zinakwanga zimepeanwa hapa. Can't seem to find them. But in this case, a maximum value at 3,000 will be enough. And then the last one need the bands we want to see. So given that the bands we want to see, there are several, we can use a list ndio tuweke hizo bands hapo ndani. So you can say band 4, band 3, and band 2. Yeah. And then the dictionary lazima ishe na semicolon. So hapa nitaandika the name of my image collection, or rather the name of your composite ambayo nimeunda, mosaic. Then the parameters I could visualize. Kisha the name of your layer yetu. Then with that in mind, I run. Now you'll see that ulipo run ungedhani hakuna kitu imefanyika, si ndio? But in real sense kitu imefanyika ni ile tu haikukupeleka to where that image is initially. So to avoid ile kutafuta pale image yako iko, because the image is right here. So to avoid hiyo, we can specify the positioning of your image yetu. So we can say map dot center object. Now the first argument ni geometry. So your geometry ni your area yetu. So we are telling the API ya kwamba once you run my code, hakisha whatever it is unaletea kwa hii viewport ni the location of your area yetu. Then the last argument is the zoom level. So we can use maybe 12. Then we end it with a semicolon. Then, kama ningeenda sehemu nyingine duniani, and then I run, taniregesha. Then, if I wanted to clip, nikwetu just an image of that area yenyewe and not just hizo images mbili zimeshikanwa, naweza kuja hapa chini niseme my Nyeri town will be that mosaic ambayo tuliunda dot clip, and I clip it to geometry. Kisha I add it to the viewport. So the first argument ni hiyo image tunataka kuona. The second is the parameters I could visualize. And the third is the name of that layer. Kinamna hivyo. So, uta notice the name of that layer nimeweka katika single quotes. So, essentially, hii ni tu kama syntax yake tu. So, utapata most of the time, these alphabetical characters was zimeweka katika double ama single quotes. So, the syntax is, if it's a string, lazima iwe katika hizo double ama single quotes. So, if I run, so tumia the var keyword. That's why imeniletea an error. Hapa imeniambia variable must be declared with var. But because sikufanya hivyo, machine ilikataa kurun. So nimekuja tu nikaiongeza. So nikirun, it will show up on my viewport, and based on the layer I want to see, I can check your layer and I can check the other one. Nando hiyo hapo. That is our area of interest. So, hiyo yote ilikuwa ni tu a recap ya chenye tulikuwa tumefanya jana. Juu watu wengi hamkufika last week. So I think it was best ningefanya tu hiyo recap kwanza. Likewise pia I can even share hizo images at the scripts na pia the Word document ambayo iko na hizo maneno yote pia. So basics pia I will share them. Alafu pia nitaeleza vizuri ndo isikae jargon. So I think hiyo itakuwa sawa. And by the way, kushika hizi codes as they are at first si rahisi. Me personally haikuwa rahisi. So you just practicing too until upate. Hadi kuna vitu vingine pia sitashika. I just copy and paste. I know how to use them. Kama a very good example ni ile umefanya maneno yote and now you want to export your image. Ufanye kazi nayo on desktop, si ndio? Now to export image yako, exporting image, we use the following code hapa. Acha nione kama ndio hii hapa. So that is the code we use. So ukiangalia hii kitu, ona kama maneno mengi. Now of course at first time si rahisi kushika kila kitu, si ndio? Alafu pia the beauty about Google Earth Engine, some of these scripts pia they're just provided within the API or rather within the platform. Now let me show you. Now we have the Earth Engine API hapa or rather code editor and the features ambayo ina contain, si ndio? Now hapa at the scripts tab, hizi ni all the scripts ambao utaandika on this platform. Now the assets ni all those items ambao umeupload onto Google Earth Engine. So for me we have hizi kangema nini, all those are just images and shape files that I uploaded onto Google Earth Engine. And then we have the doc section. Asa under the doc section sasa iko na those code snippets ambayo the Earth Engine iko nayo kurahisisha kazi. So ni nyingi sana. We have these code snippets, picture collection kama hii hapa. So ukiclick hiyo, so na iko na a lot of nini hapo, a lot of codes hapo. Kama for instance tunaweza kuja hapa kwa filter date. Sasa ona nikiclick hiyo one of those code snippets hapo ama one of those code names, so there is a short description of how it is. Shortcut to filter collection by a date range. So some of these vitu tu utazipata tu hapa kwa Earth Engine tu. So again, si lazima ukram hizi vitu vyote at first, but as long as you get to understand how they operate pia, you can just simply copy and paste alafu you edit. So kama hapa. Yeah? Naam. For the charts. Oh, natumia open source gani kulan. Okay. So kuna watu wengi ambao wanafunza hii Google Earth Engine, ndio? A lot of playlists, a lot of channels on YouTube. So personally mwenye alikuwa amenibamba ni someone by the name of Javal Gandhi. So Javal akona his own website na pia akona YouTube channel where he showcases whatever it is we are doing hapa in Google Earth Engine. So he has his website called Special Thoughts. Hadi hiyo pia I can share pia baadaye. Alafu also has a YouTube channel where I feature some of the videos pia. Kama hizo JavaScript basics pia, he has a video on the same. Now it's very, very simple too. So in case pia ulikuwa atakuendelea tu on your own pia, he is a very good teacher, unaweza mfuatilizia upate kujua more and more kuhusu hizi vitu. Alafu pia his learning is very, very structured. Anaanza from the basics to intermediate hadi to advanced. Now, let's say tumefanya kazi yetu yote. And now, we want to export our image. So, hii ndio code snippet ya export our image. Sindio? So, the syntax venye hii API imekuwa built lazima uandike export.image.toDrive. So hiyo I'm simply telling the API, hii image ambayo mimi niko nayo nataka niisukume to my Google Drive. And that's because hii Google Earth Engine venye imekuwa design, njia ya kuchukua hiyo image yako alafu load onto your personal desktop sasa ni via hiyo Google Drive yako. So after that unaweka tu parenthesis yako, hizi normal brackets. And within that normal brackets kuna a dictionary. Sindio? So a dictionary kazi yake ni ku store items in key value pairs. Now this is what I mean. Kama image, this image serves as the key, and then he clipped Kericho serves as the actual item being stored. So the items hapa, we have the image itself, the description, the folder, the file name prefix, the region, the scale, CRS na max pixels. So hii image hapa is that image you have been working on and you want to export. Sindio? Description is just a short description of what your image entail. Now, the folder is the name of that folder pale image itaenda. So hata kama hiyo folder haexist katika Google Drive yako, if you assign it a name, it's just going to generate on its own. So itatengenezewa tu. Then the file name prefix is the name of that file sasa. So these images, when they're exported, they are exported in a GeoTIFF file format. So that GeoTIFF file format has to be assigned a name. So in this, asa kama hapa, the file name prefix need the name of that file sasa. Then the region sasa new area of interest yako sasa, ambayo we give it the name geometry hapa juu. So ndio. And then the CRS in the coordinate reference system. So unapata ukifungua hizi QGIS na nini unapata imeandikwa EPSG 4326. Asa hiyo ndio unaidunga hapa sasa. Then the max pixels sasa, like unaona hizi images. These images ziko na pixels. Na hizo pixels ziko na range of values. So katika max pixels we're just assigning a value that allows these images zikuwe rendered without any bila mashida nyingi. So the advisable value ni 1 exponential 10. So that's a value ambayo na assign to those pixels kwa allow your image kuwe rendered kirahisi. And then nafunga na semicolon. So in this case, because none of these things ambayo nimeandika hapa, therefore this ni hii script hapa, I can simply just change the parameters. So nitasema tu my image ni hii Nyeri. Where is it? Kwani hatukuwa tumeclick? Interesting. Okay, so naweza mtu niseme my image ni hiyo mosaic, then my description ndasema tu mosaic export tu, kisha now the folder I'll just give it a name, mosaics folder. Kisha now my file name prefix is the name. Then the region near geometry 2 tayari. Then the scale, in other words, near spatial resolution ya hiyo image yako sasa. So in a scenario whereby pengine kama for instance Sentinel sasa, the bands I'm working with your 432 is just the red, the green and the blue. Now I know this because hapa katika hii description ya hizi image set yetu hapa kwa bands we have B1, alafu the name of B1 ni hapa katika hii description aerosols. B2 ni your blue band, like see blue band but your blue band yani. Then B3 ni green, B4 ni red, hivyo. Labda unajua each of these bands iko na particular spatial resolution. Asa hii 432 resolution yake ni 10. Now in the event utaki iko katika hiyo res ya 10 sasa, maybe utaka iko na 30, unaweza andika tu hapo 30, alafu Google Earth Engine is going to carry out resampling for you automatically. Then max pixels, then UCRS tumeandika ni hiyo, alafu max pixels tumeona ni hiyo. So with that in mind, okay, ready to export your run. Now you'll notice hapa to the far right we have inspector, we have console and we have tasks. Now hapa kwa tasks, hapo ndo palio kazi ya kuexport inajitokeza. So we have an unsubmitted task hapa. Alafu so na hii mosaic export niyo description yetu. So ukiwa tayari kuexport, you just run. Now the moment you click run, this window pops up. So hapa kwa hii window we have the task name ambayo ni mosaic export, that description. Then we have the coordinate system ambayo uliandika hapo tena ni hiyo EPSG 4326. Then scale tuliandika hapo ni 30, so nimeleta hapa ni 30. Then tumesema inaenda wapi? Kwa drive yetu. So hii cloud storage na hii Earth Engine asset, hizo ni just locations pale kitu itakuwa inaenda. So hii ni drive inatoka Google Drive yako. So naturally, because hii Google Earth Engine you use an email kuunda project na kila kitu, so Google Drive ambayo itaenda na hiyo email ambayo inashikilia hii project sasa. Then the drive folder tulispecify ni gani, si ndio? The file name pia tukaspecify. Now the file format by default is GeoTIFF. But then pia kuna other file format, but the common one is just GeoTIFF. Then na click run. So once I click run, now there is this gear shift hapa, hii gear hapa ambayo ina revolve. So once your task imemalizika, imekuwa exported fully, utaona hii tick sasa. Alafu hii 1M is simply the time it took ili image iende. So kama hapa, let me see why there's an error. Yeah. So kama hapa, okay. Interesting. Now ukiangalia error hapa, the error inasema nini? Exported bands must have compatible data types found in consistent blah 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 maneno yote. Now this kind of errors they are bound to happen, si ndio? So tunaweza fanya or rather what I think the solution is sasa, I'm supposed to select the bands I want to nataka zipatikane katika hiyo image. So kufanya hivyo, what I can do, naona hapa paliwa tulikuwa tunaandika hizo queries for the kind of images you want to see. Tunaweza mwa tuongeze hapa dot select, then tuweke bracket hivyo. So whatever itaingia katika hizo brackets ni hizi bands zetu. Kinamna hivyo. So I'm simply telling the Earth Engine API, I know that this image has a lot of bands. So ndio, tumeziona hizo zote zimekuwa listed hapo. But what I really want to work with is just those three. Before 3 na 2. Alafu, I think another issue with the error nayo pia, because the data types are kunaona kuna some inconsistency hapa. I think maybe it's because of these varying parameters hapa, kama hii special resolution na nini. Because ukiangalia the basics of remote sensing, tulikuwa tukifanya back in the practicals, tulikuwa tukiambiwa when you are stacking these bands, waweze layer stack bands ambazo kuna different special resolutions. So mnakumbuka? Yeah. So kama unapata moja iko na 20 na zingine ziko na 10, ukizelea stack hiyo kitu inaleta maneno. So the beauty with your 432, your special resolution is just the same, it's 10 meters. And because I've selected the bands ambazo mimi nataka hapa juu, huku chini kwa hizo parameters zangu za visualize, hii part ya bands naweza toa. Then let me try rerunning nione. Yeah. Let me run sasa tuone. So yeah. So itaendelea kurun. Tukiclick it drop down arrow, we see this VE, tunaona hizi vitu. We have the ID for your task yetu, then we have the phase ambayo ni running on server, then hii niyo runtime yake ambayo iko na time ambayo ilianza, then the attempt sasa ni hiyo, then priority imepewa value of 100. So tukiangalia hizi zingine hapa chini, kama hizi ambazo zilikamilika huku chini, if I click your drop down arrow, there's a bit of a difference. So na hapa phase imeandikwa nini? Completed. Then the runtime ni 1 minute. So inaonyesha wakati ilianza ambayo ilikuwa ni the 3rd of February 2025. And at this particular time ambayo ni 2:55 PM. Yeah, but there's something unafaa unote. If the two time haiko on our side, so perhaps maybe tutaangalia hiyo next session sasa. Katika hii maneno, whenever you're working with dates, whenever you want to get the current date of where you are at that particular point in time, we can use a particular function hapa. Where is it? Yeah. Now, essentially, so if I want to get the current date ya pale niko, I use the date.now function. But sasa normally katika using Google Earth Engine, it's good practice. It's normally good practice utumie like the Earth Engine API objects. So this is what I mean. Tumesema kuna hizi vitu vyote, hizo variables, you have hizo data types kama dictionaries na lists, si ndio? Now, badala kufanya machine yako ifanye hiyo kazi, you can let Google Earth Engine do your work for you. So how do you do this? We have hii date yetu hapa. Yeah. So before tukuja hapo, nimeona kazi yetu imeisha. So ona the phase imesema nini? Completed. Then the runtime imeona imesema nini? 16 seconds. Alafu sona the date ni yetu ya leo, 5th of February 2025. So nikienda to my Google Drive sasa, so I'll find it iko hapa. So if I go to my drive, I'll see my folder ndo hii hapa. My folder ndo hiyo. So niki double click na niletea nini? Mosaic image ambayo ni hiyo GeoTIFF ambayo tume export. Then if I want to work on it hapa kwa desktop sasa, maybe kama ni kuiload katika QGIS ama AirDress niunde map yangu, so I can just download it sasa. So lazima ita scan for viruses na maneno yote. So once it's ready, utaona imeingia. So I simply navigate to pali hiyo image itaingia. So for me zangu zinaingia hapa. Yeah.
So hiyo ya page.now. So tuseme machine yako inasema uko 2030. Nasema ni mjui kwanza 2030. Because the function is associated as So yes, that has some problem.
Oh, like on hii date.now, select to the current data, the time ambayo uko. Yeah. So let's say like for instance kama actually comment out hizi zote za hapa juu, then to run hizi. We see what's going to happen. Now, unaona hapa, si nimejaribu kurani kitu kwa console, lakini kaniletea numbers mimi sielewi, si ndio? So, what I can do, I've said, nimeassign a variable called now, si ndio? And here now is the date as at that particular time, or rather in this case as at now, like date ya leo, time ya leo, mambo kama hayo. But since nimeprint kitu to the console na nimeona namba za mbomi sielewi, I think ninajaribu kunyambia I can give you what you want, but kuna vitu nataka ufanye kwanza. So hizi vitu ni hizi hapa. So whatever we're doing hapa kwa hii e.date, I'm carrying out casting. So casting simply means I have my data types, whether it's a dictionary, whether it's a list, or whether it's the data. Yeah, that particular point in time, I'm carrying out this exercise. So I'm converting it into a data type that at engine can accommodate. So nikitumia the ee.date, I'm now casting you now into a date time format here at engine sasa. So sahi nikirun, ona tena niletea hapa. Let me zoom in. If I run it, what do I get? 5th of February 2025. Alafu mimi niambia ni 3 or 4, like 3, yeah, 3, inaniambia ni 3 or 409. Now the thing with Earth Engine, hii Earth Engine sasa the time ambayo itakuletea itakuwa 3 hours behind your time yako. Ndio maana hapa kwa task what I was trying to show you, ona venye maandiko hizi hii the plus 3 hours sasa. The plus 3 hours ilewekwa hapo just to accommodate hiyo maneno ya the 3 hour time difference sasa. Like it was just to show that the time ambayo tumeona hapa I think ingekuletea is 3 hours behind. And that's because to go, yeah. So that's what I was trying to show you. But given that naona time imeisha, I think hizi are thinking objects, we can discuss it better next session. Unless pengine mtu ako na a query. Yeah.
Is that function used to be, or you just use a JavaScript method, the pure JavaScript method to access existed because they somewhere so the same thing when you are document JavaScript. Because the function itself, the feedback in Piano is accurate as from machine is. So the time you are trying to take the data from that function, then converting it to some, you cast it so that it is over and easy. You're actually making it so it is inherent, what can be inherent. Inachukua here the machine. So if maybe a machine have a problem with it, it might confuse you to tell what.
Yeah, that's true actually. Yeah, because naona kama hapa, if I try to rerun, alafu nikuja kwa my console, imeletea 306, but iko 3 hours behind, so it's technically 606. Now the time on my computer, no 606 hapo. So in the event that sasa nimekosea time and date settings za lap yangu, because sasa hizo vitu viko interlinked, inaweza leta that kind of an error. So perhaps before mnatumia hii function, you can confirm ya kwamba the date time settings za lap yako pia siko sawa. Yeah. So in the interest of time, now that it is 6 minutes past 6, I beg to stop there. Alafu next session sasa tunaweza angalia hizi Earth Engine objects vizuri, ndio tuanze mambo na spectral indices sasa. Yeah. So perhaps kama mtu akona swali ama mali nataka apate clarification on, unaweza niuliza. Yeah? Yeah, nitakusukumia link ya website yake, nitakusukumia pia link ya the Google, the YouTube channel. Yeah. Yeah, so mtoto mwenye swali. Oh, and by the name, by the way, nimesahau kujiintroduce. My name is Chrysanthus Juma. Nafanya JS and remote sensing, niko 2.3.